Okay, so now that we know how to simplify radicals, we just want to talk about multiplying, dividing, and rationalizing them. So you might want to label these notes multiplying and dividing radicals. A radical, by the way, is another word for like a square root. Radicals include square roots, cube roots, fourth roots, 800th roots, whatever. So that's just another word for root. Radical is the same thing as like a root. Okay, so we got two examples here on this first slide. We're going to be multiplying radicals. So this is multiplication because they're sitting next to each other. And you might notice the problem here is that neither one of these is a perfect number. So because that's true, I'm going to multiply them together because they're both inside. This is going to become the square root of 28. Now, 28, I actually do need to simplify down further if I can. So I notice that square root of 28 has a perfect number in it, the square root of 4 and the square root of 7. The square root of 4 is 2. So this is 2 square root of 7 in the end. So remember, when you're multiplying, you can multiply things together that are inside. Notice on this next example, I have numbers both inside and outside. So when I'm multiplying, I can rearrange them. I can make this 2 times 4 times the square root of 3 times the square root of 6. So these outside numbers I can multiply together. That becomes 8. And the inside numbers I can multiply together, becoming 18. And just like today, you always need to check that whatever is left inside this square root cannot be broken down further like it was on the other one. So I can actually take a perfect number out of 18. That is not the right pen. All right, I can make this a square root of 9 and a square root of 2. The square root of 9 is 3. So remember, this is now 8 times 3, square root 2, which is going to give me 24, square root 2. Okay, those two examples, that is a little bit further than we went yesterday, but that shouldn't be too bad to talk about. All right, so let's look at dividing. Now, the same thing is going to happen with division. I can only do outside numbers with outside numbers and inside numbers with inside numbers. So for instance, right here, this 8 is inside, but the 4 is outside of a square root symbol. So I can't divide those right away. So what I'm going to do is break down this square root of 8 for a minute. Square root of 8, I know, has a square root of 4 in it and a square root of 2. And the square root of 4 is 2, so this is 2 square root 2. So when I put this all back together, 8 square root 4 is going to be equal to, erase this, is going to be equal to 2 square root 2 over 4. Now notice, now I have two outside numbers, so I can actually simplify those. And if you think about what does 2 over 4 simplify to be, you should come up with 1 over 2. So this is now 1 square root 2 over 2. And that's going to be your final answer. You cannot, I'm just reminding you, you cannot divide inside numbers with outside numbers, just like you can't multiply inside numbers with outside numbers. On this second example, though, notice that both of these are inside, which means I can actually divide them. So this can become square root of 15 over square root of 5 can simply reduce to the square root of 3, because 15 divided by 5 is 3. And then that would be your final answer. Okay, now this is where it's weird. Again, inside can't divide, inside outside can't divide. And you might say, well, square root 3 can't simplify, so this should be the answer. But, you know, that's not how mathematicians are. Remember that division is breaking things into groups. And so a long, long time ago, they didn't have calculators. And when I say a long time ago, I mean like Egyptians, pyramids, ancient Greece, like, you know, long time ago, right? So at that time, they didn't have calculators, obviously, so they couldn't divide something by a square root of 3 because they couldn't count by like the square root of 3. That wasn't something they knew how to count by. So what they did was they had to fix the fact that you were dividing by this irrational number. So what we're going to do is called rationalize the denominator, which means we need this bottom, the denominator, to be a whole number. It cannot have a square root. Cannot have square root. We need a whole number. Okay, so what I'm going to do is, this is 6 square root 3. I need this bottom number to be something that has a perfect square root. So I can do that by putting an extra square root of 3 down there, because now that I can turn that into a square root of 9, right? But I also need to fix that on the top, because I can't just multiply the bottom and not the top. So that means I'm multiplying by square root of 3 over 3. And if you think about it, I'm allowed to do that because this quantity right here just equals 1, and multiplying by 1 is going to keep it the same value. So when I multiply, this becomes, let me change colors. This is going to become 6 square root of 3 on the top over the square root of 9 on the bottom. Well, the square root of 9 is 3, right? So I'm now simplifying that bottom part. And now I can get back to where I was just a minute ago. I can simplify outside numbers with outside numbers. And 6 divided by 3 is 2. So the answer here is 2 square root 3 in the end. Now, you might need to go back and take really good notes, put question marks if there's examples you need me to go over again, but make sure you have all of those examples written down for class tomorrow.